Okay, so in the previous example, when we were working with a test on the salaries comparing male and female nurses, we actually did not have the raw data set there. We were told what the summary statistics were for the two samples. So in that case, we had to do these calculations by hand since we didn't have all of the data presented to us. In other cases, we have the raw data set given to us, and then we can use this nice built-in function in R called t.test that we've seen with confidence intervals, and as the name would imply, we can also use this t.test command to do a hypothesis test. So let's say, for example, we're looking at this data set that we've seen called NCBirths2004. So this contains like over 1,000 observations for babies that were born in North Carolina in 2004. So it's a sample. So this is not a full data set of every newborn from North Carolina in 2004. And among other things, some of the data that was collected was whether or not the birth mothers used tobacco products. So that variable was called tobacco, and there was a yes and a no group for tobacco. So that's our categorical variable that we're using to split up our population into two independent groups. Okay, so here there's no matched pair going on. Either individuals were in the tobacco group or they were not in the tobacco group. And then the variable that we're using that we would like to compare in this case is, say, the weights. So does smoking tobacco, using tobacco from the birth mother, have some effect on the weights of the babies? So it's not asked here, but what we're asked to do is set up a hypothesis test. So let me just state the hypotheses here. The null hypothesis would be that the mean of the smoking group minus the mean baby weight for the control group, I'll say the non-smoking group, is 0. Compare this to the claim in the alternative hypothesis is that there's some difference in these groups, not necessarily that one is bigger than the other. So in that case, we would say that the smoking group mean weight of those babies minus the mean weight for the non-smoking group are going to be different. So that means it's not going to be 0. And so this, keep in mind, is now going to be a two-tailed test. Okay, and so here's how the command in R works, generally speaking, and it might be not so clear what I mean by this until we see an example. So let me show you what that would look like for this case. So we're going to run the t.test command, and we're doing this on weights. So we're comparing the mean weights in each group. So this variable over here, keep in mind, is going to be numeric. Okay, always for a t-test, this is going to be when we're comparing means. So that should be a numeric variable. And then next is going to be how are we splitting up the categories. So this is going to be a categorical variable. Okay, which for us is tobacco. Okay, so this variable in the data set has either yeses or nos. And this is measuring the weight of the newborn in grams. And then we need to tell it R what data set are we referring to, where are these variables living, and this was in the data set North Carolina births 2004. And then we have an optional argument over here called alt, and so this is referring to the alternative hypothesis. And so depending on the sign that we use there, we can specify whether this is two-sided, less than, or greater than. So the options here, in addition to two-sided, are going to be sometimes we might use less if we have a less than. Sometimes we might use greater than. So that would be either less or greater would be the arguments that we would put there. And if you leave off that argument, let me just say the default is that it is going to use a two-sided test. So I didn't actually need to include this here, but I did because in general, if you have a one-sided test, then you need to specify whether that's going to the left or to the right. So that's what it would look like. So the first thing we enter is the numeric variable that we're calculating the mean of. This is a little squiggle, right? So this is a tilde. And then we describe how we're going to split up our categories. And here it's going to be whether or not the mothers said they used tobacco. And here's a look at what the output looks like. So we can see here, this is telling us we used a Welch 2-sample t-test. So in other words, the degrees of freedom that we used or approximated using Welch's approximation. So that's a more accurate estimate than the one we get by hand. And so you can see that in this case, the degrees of freedom worked out to be about 134. If we were doing this by hand, then we would have to know, in fact, how many newborns were in each of these groups, the non-smoking group versus the smoking group, and then we would need to calculate the degrees of freedom by subtracting 1 from the smaller of the sample sizes. So what we can see over here is our test statistic. Okay, so that's a pretty big value. And then in this case, it's about 4.1. And since we're doing a two-tailed test, the p-value in this case would be the area over here plus the area over here. And this is pretty far out on a normal distribution. And over here, we can see what the p-value is. And so they're using scientific notation. This means 6.08 times 10 to the minus fifth. Okay, so that's a really small value in this case. And then in case you wanted to also find the 95% confidence interval, they do tell us what the cutoffs for that would be. And so that's what's given over here. It's not relevant for our test. And here we have the mean of the two groups. So this was the mean for the group no. So this is for the group that did not use tobacco. This was their weight. And here was the mean weight for the group of mothers that said they did use tobacco while they were pregnant. And since our p-value is well below the significance level, here we can reject the null hypothesis. This is a statistically significant test, so we reject HO. And in fact, here we have evidence that we can claim there is a difference in these two means. Okay, not that one is bigger or less than the other. That was not our claim in the alternative, but we can claim that there is a difference in the mean weights between of newborns born from mothers that did use tobacco versus ones that did not use tobacco. And since we have the 95% confidence interval, let me just say that this conclusion is consistent with what we would have said if we were just looking at the 95% confidence interval, because this confidence interval for a difference in means only contains positive values. It does not contain 0. So that would indicate that we do have evidence that there is a difference in the means of these two groups. So that's how we can use R to calculate this when we have the full data set in R. But let me just again note that in the previous example for the male and female nurse salaries, since we did not have the full data set, we only had summary statistics, then the best that we could do was approximate the test statistic by hand using the formula.